they do classes and stuff, and like I spend days out in the fields with them. So, yeah.
So field work is really important to you.
Yeah. Well, I think it's gaining experience.
Okay.
Yeah.
Good.
What do
You gotta get your dirt
yourself doing
cred.
in the future with it? Like, imagine yourself like in 5 or 10 or 20 years.
Yeah.
What would you be doing on a day-to-day basis?
I want to be like on farms, just learning and then sharing my knowledge just to on farms around the world, just to make them a better, more efficient system. That's what I want to do.
Okay.
Yeah.
That's when I think math will begin to come into things, and that's when I think you'll find that mathematics will begin to interest you.
Yeah.
When you try to think about efficiency.
Yeah.
That's
But the problem is now, like, I know that someday I'll probably need math, but like I like sit down with a math packet and I look at it, I'm like, this is stupid. Like, I'm never gonna need this problem, you know. What's important for me is I need like.
It's the wrong way to learn math.
I need like a packet of like a real world problem, you know,
Right.
like how are we gonna solve this problem, and then like take the steps for that. Cause like when I just get that bullshit on a paper, I'm just like, that's useless.
You'll have no
in my
trouble
mind.
learning math.
Yeah.
You don't ever say to yourself that you're bad at math. Okay.
Yeah.
What you're bad at is you're bad at
Following the system.
learning math badly. You are not good at learning math badly. You are only good at learning math properly. And the proper way to learn mathematics is to be faced with ill-structured problems.
Yeah.
To figure out that you care about. By the way, ill-structured problems that you care about. Let me give you an example. I'll bet you that if you and I worked through the mathematics of analyzing statistically the performance of different fertilizers, different kinds of fertilizer, by trying different test plots, laying them out, and then trying different fertilizers or some different fertilizing methods or something like that, and then measuring the yield, and then plugging that into equations that could tell us which of the methods under those conditions was most effective, that you wouldn't have any trouble. I could talk you through that and you go, oh, cool, it's a statistical tool that we could use to tell how effective our methods are.
That's interesting.
In fact, that was where a fellow named R.A. Fisher first invented the field of what's called design of experiments. He invented it in order to test fertilizers.
Yeah. Well, what would be even more interesting is testing the fertilizers, testing the normal soil, and then testing the like examples that we have that have you apply permaculture like designs to. You see what I'm saying? So like we have the fertilizers, the normal, and then like this permaculture technique, and seeing, I think we would see that the permaculture could bring more yield.
And then once you realize what the statistical tools are, what'll happen is you learn them to solve a problem. You forget them, but what you do, even though you forget them, is you do this.
I'm gonna go fill up my cup of tea real quick.
You get this.
I'll be right back. Howdy.
Hey.
If it's their passion, if they want to be a doctor, they do have to learn the math, and that will make sense to them because they want to do it. The reason so many people hate math is not very many people need math, and we're forcing everyone to take it. So he's not saying that the math is bad. He's just saying the mandatory math. The math that we teach.
There's a good way to learn math and a stupid way to learn math. I'm interested in economics, but when I read an economics textbook, what they just give me is idea after idea after idea, completely disconnected with anything I'm interested in. So I lose interest very quickly in learning about quantitative economics. But I had to solve a statistical problem recently that made this card really, really interesting and important to me. This card I had in case I needed to solve a statistics problem. And then suddenly, I had a statistics problem I needed to solve, and this card went from being stuck behind a bookcase somewhere to right in my briefcase, and I carry it around with me because I'm in the middle of dealing with some important statistical problems that I really need to solve. So once you learn the basics about statistics because you have a problem to solve, then what will happen is you'll forget it. And that's okay. Don't worry about forgetting math. Because you forget it, but then you have a little card like this that when you need to learn it again, it'll be faster to learn it the second time because you just look this stuff up and you go, oh yeah, I remember. That's how I do a standard deviation. Okay, I got it. Of course, the most important thing with statistics mathematics, and actually it's true for most mathematics, is you never need to know how to actually calculate the equations because they're all built into spreadsheets. What you need to know is, how do you know this is the equation you need to use? How do you know that this is the right time to use it and that you have the right prerequisites to make it work? That's what messes people up. And actually, in fact, people who think they're good at math are often actually bad at math. What they're good at is cranking out simple answers to simple problems. But what they're bad at is knowing when they have that problem. And so
that's exactly the computerized math that Conrad Wolfram is trying to push. And we're going to pilot it. Hans wants to pilot it this semester. So maybe you
well, with my son, I want to be part of that, actually. I'm eager to help you with that. My son had to take a standardized math test as part of his homeschooling thing. And so I gleefully encourage him to cheat like crazy. And it's interesting to me that he doesn't cheat. He tries not to in many cases. Because I don't recognize the legitimacy of the test. But at one point he decided he was going to try to use Wolfram Alpha to solve all the math problems on this test. It turns out that that's an interesting challenge all by itself. Because you have to know how to word the problem so that Wolfram Alpha will give you a good answer.
He's actually asking for people that would help with the courseware and what you're talking about, making it useful and easy, because he really wants this to become like, this is how we do math now. So he needs to make it user-friendly.
Yeah, there's lots of articles out there actually about how math is taught in a way that doesn't help people learn it, and it makes them hate it actually. And I see, that's why when I teach testing, I don't teach testing by telling you a bunch of techniques. Okay, here's equivalence class partitioning. I'm going to tell you about equivalence class partitioning. You should do it. Okay, instead what I do is I say, what's this? Can you tell me what this object is? That's how I teach testing. I begin by giving you something and challenging you to discover a secret about it. There's a secret about this object that I know that you don't know. See if you can find out what it is. Okay, I want you to just try this. Describe that object for me, please.
It's a bouncy ball.
Okay.
It's black and round, and
I want you to notice something about what you're saying right off the bat. You said it's a bouncy ball. You said it's black and round. Now, let's focus on black. Okay. Is it a black ball?
Yes.
Are you sure that it's black?
No, I'm not.
Oh, but you just said it was.
Yeah, that was an observation.
Well, was it an observation?
Okay, it may be
Was
black.
it an incorrect? Oh, it may be black.
Yeah.
Okay. So now you're using what we call in testing safety language.
Okay.
Safety language is little qualifiers that you put on. You basically look at it and you say it appears to be black. If you bring it out in bright sunlight and it starts glowing iridescent purple with little sparklies in it, you go, oh, it's iridescent purple with little sparklies. And I said, but you said it was black. And I said, no, I said it appeared to be black. And then what it did appear to be black. It doesn't appear to be black anymore, but it did at that time under that light. Okay, so I just want to point that out because as I teach people to be professional observers, anyone who's a scientist or anyone needs to be a professional observer, then I need them to begin to be a little more precise in their observations of things. So you'd say it's black, you say it's round, you say it's a bouncy ball. Is there anything else you want to describe about it?
There's like a equator on it.